I'm Anil Kumar. Welcome to my series on trigonometry. We'll discuss transformation of some trigonometric functions in this particular video. For the function f of x equals to sine x, sketch one cycle. So we have to sketch only one cycle of the following graphs. Now here we need to explain key features, and second part is write domain and range of each transformed function, right? So these are different transform functions given to you. You can actually pause the video, answer this question, and then look into my suggestions. Now when we say key features, what do we mean? So let's list the key features which we are going to discuss in this particular video. Now key features for a sinusoidal function will be amplitude, right? We can have time period, phase shift, axis. So these basically are the key features of a sinusoidal function. Now the other key features could be, you could say when we have domain and range, right? So we'll write domain and range here. Domain for any sine function is all real numbers. However, we are considering one cycle, right? Since we are considering one cycle, we want x to be we'll take it between 0 degrees to 360 degrees. Is that clear? So we'll choose one domain as 0 to 360 degrees. That is one part. Second part to understand here is that generally a transformed function g of x will be written as a times, let's write sine in terms of sine x, right? So sine of k, x minus, let's say d plus c, right? So if you have this kind of a transformed function, then the coordinates of the points from the function sine x, let's say if they have x and y, then they get transformed and their image is going to be at x over k, right, plus d. So that is how the x point will change, and the y point will get multiplied by coordinates, right, a, and then that's it, and then you add c to it, right? So that becomes the new coordinates. So that becomes the new coordinates for your particular function. So when you are taking sine x as your coordinate, let me just complete this here, then what we are going to consider is x and y values. We can take x values and then sine x values. So 0 degrees, right, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, correct? At 0 degrees, sine value is 0. At 90, it is 1. So it goes up, comes down, -1, and then back to 0, correct? So those are your x, y coordinates. Is that clear, right? So this is y equals to sine x. So with that brief introduction, let's begin and understand how to explain the key features of the given transformed functions and also how to find domain and range. You can actually pause the video, answer this question on your own, and then look into my suggestions, right? So I'll begin with the transformation of the points, right? So we already had discussed just now, if we have a function f of x as sine x, let's say f of x as sine x, then the coordinate points are 0, 0, right? At 90 degrees, sine value is 1, and at 180 degrees, it becomes 0 again, and at 270 degrees, we get -1, and at 360 degrees, we get the value back to 0. So there are 3 zeros in one particular sine wave. So that is our domain, okay, 0 to 360 degrees. The transformation for us is what? So we are saying f of, within brackets, 2 times x minus 30. Now when things are within brackets, there is no change in y values, correct? So the transformation here will be if you consider xy as the coordinate of any point on the function, then as far as the image is concerned, the x values will change. We'll have this factor half, and then we'll add 30, moving it to the right by 30 degrees, but the y values will remain same. Is that clear to you? Perfect. So doing this calculation, what we are going to get, so we'll just divide this by 2 and add 30, right? So if you add 30, you get 30 here itself. The y values will remain same, correct? Divide by 2 is 45. So 45 plus 30 is 75 degrees. The y value will remain same. So 90, half of 180, plus 30 is 120 degrees, and y value remains same. So let's do this. 270 divided by 2, and then to this we add 30. We get a number 165. Y is minus 1. 180 plus 30 is 210. Y value is 0. So those are your transform points, correct? So that is how it is. As far as the key features are concerned, let me sketch this function also, and then we will actually write down the key features. Okay. If I write this function y, which is basically equals to f of 2 of x minus 30, x values change to all this, right? So we have this function as sine of, right? So within brackets, x value change to this gives you 2 times x minus 30, correct? 30 degrees. Is that clear to you? So that becomes your transformed function. Now in this function, the amplitude is 1, right? So let's write down the key features. Okay, so let me write down key features here. Now it's your option. You could actually sketch first and then write down the key features, or whatever you feel better, or you could write key features and then sketch. All right. As far as I'm concerned, I like to sketch first. It is actually better. In this particular case, what we are seeing here is there's a phase shift of 30 degrees, right? It moves right to 30 degrees. The time period is becoming half, right? So that is the transformation. So basically what I could do is I could just, I'm making a slightly a bigger and clear picture here. We do have the sine wave here, and as you can see, it starts from 0 at 30, right, which is this particular point here, and it ends at 210 right there, so which is 210 degrees. Do you see that? So that becomes your one wave. The amplitude is from axis to the maximum value, which remains at 1, as you can see clearly from this set of values. Perfect. So I have actually drawn this graph using the set of values here. Is that clear to you? So those are my values. Perfect. And that's my graph. Now once you have a graph in there, it is easier for you to write down all the key features, correct? So let's write down the key features, starting with the amplitude, which is the distance from here to there, right, from the axis to this. So we have amplitude of equal to 1 unit, right, and we have axis at y equals to 0. We have phase shift of 30 degrees to the right. Time period is basically, because of this 2, that 360 degrees gets divided by 2, so we have 180 degrees. So you'll find 210 minus 30, right? So which is also, you can calculate 210 minus 30 degrees, where you get the same answer as 180, correct? So these are your features, and what you also now can say that the domain of the function is from 30 degrees, since it's shifted 30 degrees to 210 degrees. Do you see that? One particular wave, it gets compressed by a factor of half, correct? And the range remains the same, which is from -1 to 1, correct? So the key feature, what you also notice here, is that the horizontally compressed by a factor of 2. That is first transformation, and the second one here is shift 30 units right. Is that clear? So you could describe the transformation as I have written here. So that actually completely explains what is expected of you in this kind of questions. I hope that is absolutely clear. Okay, now let's take the next example, which for us is similar to what we had earlier. However, there is a difference. So I'd like you to pause this particular video and then answer this. Okay, so in our case now we are given equation as y equals to f of something. So it is sine, replacing x value with all this. So sine of minus 0.5x, and then we have plus 30 degrees minus 1, right? So that is what it is. So now whenever you have an equation of this form, it's a good idea to factor the coefficient of x. So we get here sine of minus half. Let me write this like this. Is it okay? Now that will change this sign to negative, right? And gets multiplied. You get 60 degrees. So the phase shift is not 30 degrees to left, but it is 60 degrees to right. Do you understand this portion? Perfect. Now that is very important to understand. If you make a mistake here, everything goes wrong. So a general point, which is xy on sine of x, will now get transformed, and the x value will be negative 2 times the original value, right? Since it is half. And then you have to add 60 degrees, right? So that is the x value. From y you have to take away 1, correct? So that becomes your transformed point. So getting back to our set of values which we had taken earlier. So for sine x, okay, so here we have sine x, right? And here we have the modified function which is given here. So we have y, which is a transform function, where that is the kind of transformation. Is that clear to you? Okay, so the sine value are at 0, we know it is 0, right? At 90 degrees it is 1. It goes through 180 degrees x-intercept, 270 degrees is minus 1, and at 360 degrees it is back to 0. So now to calculate the x and y values, you have to multiply this by negative to add 60. So we get 60 here. The y value is negative 1. Since this is translated 1 unit down, correct? So let's use the calculator, quickly write down all our answers. So 90 will multiply by minus 2, right? So we'll do 90 times, within brackets, let's say minus 2, and then we'll add 60 to it. So we get minus 120, right? So this position is minus 120. Taking away 1 from 1 gives us 0. Now 180, so we'll just change this 90 and make it 180, correct? So we'll just make it 18, and then what we get is minus 300. So minus 300, and this becomes minus 1. Now we're going to change 180 to 270, right? So 27, and that gives us minus 480, and the value is minus 2, and then we have 360. Okay, so this is a quick way of calculating all the values. So we get minus 660, and the value here is minus 2. Okay, so what do you notice here? You notice that definitely the time period has increased. It has gone to 720, twice what it was, correct? So let's describe the key features, and then we'll kind of sketch it also. Okay, so let me describe the key features here we are going to sketch in this portion. Okay, so the key features will be what? So in key features, you can say from here that the amplitude remains same, right? So amplitude is still 1, and the phase shift is 60 to the right, correct? So that means 60 to the right, 60 degrees right. And this is reflection on y-axis. So we have a horizontal reflection. Let me write horizontal here in short. So the whole thing flips on this side, and that's why you get all these negative numbers, correct? The time period is twice 360, right? 360 times 2, which is 720 degrees, which you can easily see from here, correct? So the whole wave actually has come on the left side. So let me sketch it here. So since we are drawing on the left side, so I'll take this opportunity to shift my axis to further right. So this -1 tells you that the axis has come down by 1 unit, right? So this is y equals to -1. So let me write down this here. Axis is y equals to -1, correct? So now the wave actually is on the left side of the curve. So it is kind of like going like this. Do you see that? So we have one full wave going like this. It gets reflected, correct? So that is how the position is. And as you can see from the calculations which we just made, what we get here is, sorry, I should have started from the right. It is plus 60 here. I'm sorry. So this I made as -60. Let me redo. This is wrong. Okay, so let's redo. Okay. So the points which are given to us are kind of like this. So we have here y equals to 0. Okay. So the interval is from 60, and then it's like -120, right? So let's say this is 60. I'm making this smaller now so that I could sketch the whole wave within the space which I have. So let's say this is 60 for us, okay? So 60, and then this is -60 for us, okay? And then this is 120, so we'll have these demarcations. Okay. So, okay, correct. So that is our axis, and as you can see, the wave starts with the -1 value where the axis is, right? It starts from here, and then from here it goes to 0 when it is -120. So here 0 minus, that is where it goes 0, right? And then it comes back to -1 kind of here, right? So it is 60 more kind of here, and then it goes to this place, and then it goes up, correct? So okay. So we have a stretched wave here. Does it make sense to you? So that is our wave. So I had to squeeze it in here. Anyway, those are the points which will help you locate exactly what we meant. Is that clear to you? So this point here is at this is at 60, and this point here is at -660, okay? So this is the last point here. Is that clear to you? Correct. So that is how we are going to do it. So now let me write domain and range. So domain basically is from -660 to 60. Is that okay? That becomes the domain. And as far as the range is concerned, you can see it is from -2 to 0. So it is from -2 to 0, where this minimum is at -2. That is your -1. Perfect. So that is how we are going to get domain and range for our function. So I hope that makes sense. So ignore the first wrong sketch. I started at the wrong point. This was actually +60. So that is the correct one. Is it okay? Now let's move on and take the next. So I hope you have understood all these steps involved in writing transformations, sketching the graph of trigonometric transform functions, and finding its domain and range. So I'd like you to pause the video, answer this question, and then look into my suggestions, right? So we'll begin with the set of points itself, and let us also understand the transformation. Originally, the point will be x and y, and here you see clearly -3 means vertical stretch by a factor of 3 in reflection on x-axis, and +1 will move it 1 unit up. Horizontally, it translates 30 to left. So the x values will be x minus 30 degrees, and the y values will get multiplied by minus 3, and then you have to add 1, correct? So that becomes your transformation. The original points will take 0 degrees will give me 0, 90 degrees will give me 1, 180 degree will give me back to 0, 270 degrees to minus 1, and 360 degrees to 0 for one full sine wave. Now, to calculate these values, what we will do here is that we'll write their x and y values. This time both are changing. So take away 30 from the x values, so we get this, correct? Just take away 30 and you get your values in degrees for x, correct? So the graph has shifted 30 units to the left. To the y values, we are multiplying first by negative 3 and then adding 1. So negative 3 and 1 will give you 1 for this. Negative 3 plus 1 will be negative 2. Here it will be back to 1. Negative 3 and negative 1 becomes positive 3. And when you add 1, it becomes 4. And in this particular case, it is going to be 1. So what you notice here is that the range is from minus 2 to 4. And the amplitude basically is my 3 units, right, between the axis of 1 and the maximum value of 4. So that gives you the amplitude, correct? So with this in mind, since we have a function which has been transformed, let's sketch the function first this time, okay? So we are using this particular graph. The axis here moved 1 unit up, right? So let's say this is 1 for us. So that is the axis. The maximum value is 4 and the minimum is 1. Since the minimum is minus 2, right? So we have 1 and minus 2 here. Okay, I should have drawn slightly below. Anyway, so what we will do here is we'll kind of sketch this further. Okay. So the minimum value is kind of here on this line, and the maximum value, same distance away, let's say somewhere here, okay. So the graph of the function starts with minus 30 and then it goes kind of from here to a maximum, then back here, and then it goes to this value. So we'll just sketch a graph, a sine wave here. Correct? You have the coordinate points which are right there. The values here are from, so this is minus 30 for us, correct? And it ends at 330. This is the maximum of 4 and this is minimum of minus 2. So now you can write down everything, correct? So we have amplitude, which is equal to this distance, which is 4 minus 1, or equal to 3, correct? So we have amplitude of 3. Phase shift is 30 units left. Time period is same, 360 degrees. Now, as far as the axis is concerned, it is at 1, y equals to 1. Domain for one wave, right? So domain for one wave is from minus 30 to 330. And the range is from a value of negative 2 to 4. Is that clear to you? So that is how you're going to get your answer. So I hope it has become easy, right? The last question here is for you to do. It combines everything in itself, right? So you can actually pause the video, answer this question, and here is a quick solution to the same. So we have x and y values here which will get transformed. As far as the x value is concerned, what you should do, you have to factor out 3, correct? And once you do that, you get this divided by 3 is 20 degrees, right? Now you'll be in a position to correctly write down, correct? So the x values will get divided by 3 and then you have to add 20, right? As far as the y values are concerned, they get divided by half and you have to add 5, correct? So those are your values. I would like you to fill this up, correct? And sketch the graph. Also write domain and range. So treat this as your test question, right? So as far as the graph is concerned, what do you expect? You expect the whole graph to move up by 5 units, right? So I'm this time sketching it here. We say, well, our axis here is, this is y equals to 5. The amplitude here is only half, right? So the maximum minimum values will be somewhere here, correct? And what you also notice is that it has shifted 30 degrees to the right, and 3 means the time period has shifted, has been squeezed horizontally by a factor of 3, right? So you have a wave which is kind of like this. Do you see that? So that will be your wave. So this point here will definitely be 20 degrees, and the time period here will be what? So let me write down a few values. Time period will be 360 degrees divided by 3, which is 120 degrees. So if I add 120 degrees here, we get 140 degrees, correct? Maximum and minimum values will be, this is 5 and this will be 5.5 and that will be 4.5. Do you get the idea, right? So that is going to be our function, right, as you can see. Now I think the answer is absolutely clear. I would like you to pause the video, answer all these questions, and then you can always look into some related questions. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.